Welcome back to my AP Calculus class. I will keep explaining Riemann sum. Today's Riemann sum is RRAM, right rectangular approximation method. I'm going to use the same three steps I already explained in LRAM in the last video. Let's start. I use the same function y is equal to x squared plus 1. The graph looks like this. Y-intercept is 1, and then opens up parabola. So, like this, right? And then I'm going to find that area under the curve with the x-axis when x equals 0 to when x equals 1. This is 1. If x is 1, the y value will be 2. Then y-intercept is 1. I want to find this shaded area under the curve with the x-axis. I use 4 rectangles area first. Okay, step 1, 4 rectangles. Step 1. Okay, I'll divide equal 4 subsections, 4 subintervals from 0 to 1. So half is 1/2, 1/4, 3/4. 1/4, this part is 2/4, and 3/4. Then 0 means 0/4, 1 means 4/4. Okay, why I use 4/4 instead of 1 to find the pattern, for the second step. And rectangles area. What is the first rectangles area? It is RRAM. So R means right and the point of each section gonna be used. The first subsection is from 0 to 1/4. And then I'm gonna find that right end point 1/4 on the graph. And then I draw rectangles. Something like this, right? What is this area? 1/4 is length times height. That height is y value when x equals 1/4. So plug in 1/4 for x. 1/4 squared plus 1. That's the first rectangle's area, right? What about second rectangles? I'm going to use the right side for right end point of second subinterval from 1/4 to 2/4. That means x equals 2/4. So on the graph, draw the rectangles. These rectangles, right? What is the area? 1/4. Length is 1/4 always. That height is y value when x equals 2/4. So plug in 2/4 into the function equation. So 2/4 squared plus 1. What about third one? Third rectangle is this. Draw the rectangle at x equals 3/4 because 3/4 is the right side point on that interval. These rectangles, right? What is the area? 1/4 times height is y value when x equals 3/4. Plug in 3/4x. So 3/4 squared plus 1. The last fourth rectangle's area is this. Okay, draw the rectangle at x equals 4/4. Y value of 4/4 is the height. So last fourth rectangle's area is 1/4 times 4/4 squared plus 1. Okay, we're going to find the sum of all these 4 rectangles area. 1/4 is a common factor of each part. And then 1 square over 4 square plus 2 square over 4 square plus 3 square over 4 square, 4 square over 4 square. So 1 square plus 2 square plus 3 square plus 4 square over 4 square. And then how many ones? 1, 2, 3, 4 ones. So plus 4. Okay, if we calculate this, 1/4 times, it is 1 plus 4 plus 9 plus 16 it is 30 over 42 plus 4. So 1 over 4 times 15 over 21 plus 4. So 15 over 84. I multiply these two plus 1. So 84 plus 15, 99 over 84. Okay. This is 4 rectangles area, right? This rectangles area supposed to be overestimated because the rectangles area actually bigger than actual area under the curve, right? How much bigger? Just this much bigger. This much bigger, right? Yep. So in this case, RRAM is overestimated. Not always, because this case graph is increasing function graph. Mostly increasing function graph, if you find the RRAM value, that's overestimated, usually. Second step is what? Second step is find n rectangles area, not 4 rectangles area, n rectangles area. Okay, let's go to the second step now. Step 2. This is 1, 0. If we found n rectangles, we have to make a sub-interval. How many? N sub-intervals with the same interval, right? So if we're going to make a fourth rectangle using right side point, these rectangles, this point was 1 over 4 when we made 4 rectangles, in this case n rectangles, so 1 over n. 1 over n, right? So fourth rectangle's area is this. 1 over n times y value n, x equals n over 1. And then that function is y equals x squared plus 1, right? So plug in 1 over n for x. What is the second rectangle's area? It is same length. This part is n over 2 over n. So 1 over n times y value n x equals 2 over n. 2 over n squared plus 1. Keep going like this, right? Then what about the last one? The last rectangle looks like this because we're going to use the right side point. So this is 1. 1 means n over n. So last one is 1 over n times n over n squared plus 1. What is the sum of all these things in terms of n? Okay, 1 over n is common factor. And then I'm going to gather all this part together. 1 over n squared, 2 over n squared to n over n squared. That is 1 squared plus 2 squared plus until n squared all over n squared plus how many ones over there? N ones. So plus n. Okay, I will do distributive property first. I'm going to multiply these two things and these two things. So it will be changed. 1 squared plus 2 squared plus until n squared over n times n squared is n cubed. Then 1 over n times n is plus just 1. That makes sense, right? And then I'm going to use sigma notation for this part. I can change sigma k equals 1 to nk squared over n cubed plus 1. And then what was the formula? sigma k square was n times n plus 1 times 2n plus 1 over 6 divided by n cube, 6n cube plus 1. This is the answer. This is the area of n rectangles using RRAM. Okay, let's go step 3. Step 3, I'm going to find now not just n rectangles area, right? I'm going to find how many rectangles area? Infinite number of rectangles area. How many? Infinite number of rectangles area. How can you find that? Okay, we just find the n rectangles area, right? What was that? N rectangles area was n times n plus 1 times 2n plus 1 over 6n cubed plus 1. And then now I'm going to use this to find the infinite number of rectangles area. How? We use the limit concept in RRAM. For RRAM, exactly the same thing. Just make a limit and approach to infinity. That exactly represents n rectangles area, right? The first part, this part is infinity or infinity form. They're going to be limit and approach to infinity to n cubed plus something. I don't care the other part. Then 6n cubed. And then plus 1. 1 doesn't increase any n, so 1 is 1. This is infinity over infinity form. So we've compared degrees, and then top and bottom had the same degree. What is the answer? Leading coefficient was always answer. Okay, you learned that in the pre-calculus class as well. So 2 over 6, 1 over 1/3, plus still 1, 4 over 3 is infinite number of rectangles area. That infinite number of rectangles area exactly equal to area under the curve between x equals 0 and x equals 1, something like this. We found that this graph y equals x cubed plus 1. 0, 2, 1. We just find what? This area under the curve with the x-axis. What concept we used? We found that just n rectangles area, and then we used the limit concept to find the infinite number of rectangles area. That is exactly equal to area under the curve. This is basic concept about RRAM. In the next video, I'm going to explain MRAM, which means we're going to use midpoint instead of a left end point or right end point. MRAM going to be next video. Thank you so much for watching my video. Click subscribe and like and turn on the notification. Thank you so much. Bye-bye.